8.3 today, geometric sequences and series. At the top of page 228, you have some vocab terms that we'll reference today. You can go ahead and define those at a later time if you want. Most likely, we've referenced them enough in 8.1 that you may already know them. But geometric sequence, if you think back to algebra, this is one of the sequences you covered. You may not remember it, but you did. A sub n is equal to a sub 1 times r to the n minus 1 power. Okay, and we've talked a few times in here about the different forms. If we have the first term of 2 and a common ratio of 3, we'd have 2 times 3 to the n minus 1. The ratio is there. A sub 1 is there. Now, back in 8.1, we had a conversation in here about, like, look, couldn't I write this same thing by finding a sub 0, which is my y-intercept. Think about when, my y-intercept, when x is 0. And, dividing this by, or this 2 by another 3. So you'd have a sub n is equal to 2/3 times 3 to the nth power. Okay? And that is actually that's valid for this. It's just the geometric sequence formula is this right here, where we can easily pick out a sub 1, and we can easily pick out our ratio, which we'll actually use in this formula right here. We use a sub 1 in this formula. So if you're here, really this is a sub 0. So those of you who have used this formula, and I know Em and I have talked about it, and I talked to a couple other students about it, some in this class. Mostly, we had 1 or 2 in the other class that were doing it as well. Really what you're finding here is a sub 0 then, okay, not a sub 1. And when you use your summation formula, a sub 1 we use right here, so it's really nice to have a sub 1, which is why we try to keep our geometric sequence in that formula. So I'm not going to reference that. I'm going to keep it like this being a sub 1 and that being r. Okay? Though they do equal the same thing. All right. Questions there? All right. I want you to take a look at the sum of a finite. What's finite mean? It stops, okay? Sum of a finite series. Why can r not equal 1? You have 0 on the bottom, yeah. Okay, so r cannot be 1 there. Can't be multiplying by 1. All right? Okay, I want you to take a look at problems 1 through 4 on page 229. And I want you to give number 1 and 2 a shot there. Okay, is 1 geometric? Yep. What's the ratio? Hey, you're multiplying by 3 each time. All right. Number 2, geometric. No. What are you doing every time? Good. Subtracting 5 or adding negative 5, if you want to think of it that way. This one's an arithmetic. Okay? So there's no common ratio. All right. Number 3, let's take a look at that one there. Sometimes, here is pretty evident that you're multiplying by 3. Sometimes it's a little tougher to figure out what you're multiplying by. Some of you look at that and you figure it out easily. 13 times what is 78? But you could, if you're not sure, if you take this and divide it by the previous, okay, you get 6. I want you to take that and divide it by that divided by that. Make sure they all match. There. Yeah, well, this is exponential. When we studied exponents, we did this earlier. Yeah. So that divided by that divided by that, they all equal 6. Okay, so if you're ever having a hard time figuring out if you're multiplying by a common amount, just do division. Work backwards. Say this divided by that. Okay, which makes sense. If I'm multiplying by 6 this way, then this way I better be dividing by 6. Right? Okay. Anyway, in this case, yes, it has a common ratio of 6. All right. You want to figure out number 4? Kind of taking a look at it. Times 1 there. -2 there. So R is -1/2. That pattern continues. Okay? You keep doing it all the way down. So yes, this is geometric as well. Okay, so with fractions, just top and bottom, kind of like we've worked on. Okay, any questions so far? Holy moly. All right. Hey, give number 5 and 6, or number 5 and 7 a go, please. These two here. Okay, in order to write your rule, you need to know a sub 1 and r. A sub 1 is our first term. R multiplied by 3 each time. So we get a sub n is equal to a sub 1 times r to the n minus 1. So a sub n is equal to 6 times 3 to the n minus 1. If we want to find a sub 6, we've got to plug in 6 here. So that makes that the 5th power, which is, box our formula there. 3 to the 5th times 6 gives us 1,458. Okay. Questions? Number 7, we're dealing with the dreaded fractions, right? R, that's 1 over 1, multiplying by 2 each time. On the bottom, on the top, how about that? Times 5 each time. Okay, all the way through. A sub 1 is 1. So when you write your equation here, when you put a sub 1 in, you put that 1 for a sub 1, and then multiply it by r. Make sure r is in parentheses. And do we need the 1? No. Okay, just kind of get rid of that. Anything times 1 is itself. And so when we plug in that 6, it makes that 5 up there. So a sub, that should be a sub 6. A sub 6 is equal to 3,125 over 32. Make sure you're raising both parts to the 5th power. Okay, questions? This chapter seems like we hit it hard in 8.1, and then the like 8.2 shouldn't have been too tough. And 8.3 is kind of the same idea. You're narrowing our focus a bit. Okay, 2 problems left. Number 10. We're going to skip 9 for now. Number 10, and then we'll do number 12. But let's start with number 10. Write a rule for the nth term of the sequence. Number 10. All right. Hey, guys, remember your equation. A sub n is equal to r times, or excuse me, a sub 1. Meaning we need to know a sub 1. We need to know r. They do not tell us either of those. So they do give me some points. Okay, they give me when a sub n is 54. That's the 3rd term, meaning this is actually r squared now, right? And so we could say 54 is equal to a sub 1 times r squared. We still have 2 variables. So if I solve for one variable, say like a sub 1, so divide by r squared on both sides, I get 54 divided by r squared equals a sub 1. Why would I even do that? Because then I can substitute it into another equation for a sub n, where a sub n, or a sub 6, is 1458. okay, which makes that r to the fifth. If I plug this piece in now using substitution, remember our old skill there, for a sub 1 I get 1458 is equal to 54 over r squared times r to the fifth, which, multiplying that out, you do some cross reducing, you end up with 1458 equals 54r cubed. So r cubed is 27 and r is 3. If r is 3, we can use that right here, 54 divided by 3 squared. Plug that 3 in for r. That's equal to a sub 1. So a sub 1 is 54 divided by 9 is 6. So we get a sub n is equal to 6 times 3 to the n minus 1. And that is our equation. Okay? Now, or our rule if you were using their terminology. Now, I believe that is a long way. Some of you will use a more intuitive process, which is fine. If you don't, this is a very concrete way you can use. Yes? Let's hear your way.
Okay, so what I did to find r was I took a to the 6, so I took 1,458 and I divided it by the 54, and then I cube rooted it, like I took the cube root.
How did you get the cube root?
Because the difference was 3, and so since the difference was 3 from there, then I knew that I'd have to take the cube root because then it would just be multiplying by 3 each time. And so,
okay, can I pause you real quick?
Yeah.
So 1458 divided by 54,
And then I got 27.
you get 6 minus 3 here. Okay? And this gives you 27 equals r cubed. Take the cubed root, so 3 equals r. Could you do that? Yes, you could. Okay? Now, please understand why that works. Okay? And for those of you who are like, I don't get it, well then don't use it. I mean, but really what it does is it jumps you right down to here in the process. Okay, but what's happening there is if you have n and a sub n, they don't give you a sub 1 or a sub 2, but they do give you a sub 3. It's 54. They don't give you 4. They don't give you 5. But they do give you 6. They tell you that's 1458. Okay, so you could look at it in this sense. You're like, well, here I'm multiplying by a common amount 3 different times. And here I'm increasing by 1 each time. Right? And so really, to find the ratio from here to here, I just divide those two things like we talked about a minute ago. 1458 divided by 54. That's how much it would take to multiply from here all the way to there. We know that that is 3 steps. Okay? And so once we get there, we have to think, well, I multiplied by a common amount 3 different times. Okay? So that's why I take the cubed root of that. That would be completely fine to do. In fact, if you wanted to work backwards from here, once you know r, you can say, well, I'm going to divide by 3. And then I'm going to divide by 3. If I divide by 3 once, what do I end up with? Something. Huh? 18. And then I divide by 3 again, I get 6, which is what that was. Could you do that? Yes. Is that faster? I think so. Will everyone understand it right away? No. Therefore, you have a concrete method. And by the way, the book will walk you through this method. Okay? Either one's fine with me. Questions there? That's quite a mess up there. Just saying. I missed where you're at. Right here? Here. Okay. So here I'm just multiplying out. So r squared and r to the fifth, you cancel. You're dividing out. So you have r times r and r times r times r times r times r. So you're left with r cubed. Okay. Other questions? Okay. Why don't you take a look at number 12. Try to separate it from the mess we just had. All right. I would like you to apply our formula for the sum of a finite series. Sum of a finite geometric series. In fact, that formula is on the previous page. I'll write it up here as well. That way we all have it on the same page. Okay. Go ahead and apply it the best you can there. Okay, remember this is a sub 1. Yeah. This is r. Remember, this rule right here is just our a sub, let me zoom out a bit. That rule right there is just the a sub n is equal to 3 times 3 halves to the n minus 1. That's all that is. Okay? They're just dropping that chunk of it and putting in the summation and saying how far we're finding the sum. You're starting in this case at, well, we'll use n equals 0, and you're going to 10. Okay? And so this would be 3 times 1 minus 3 halves, in parentheses. What term are we looking for? Okay, going out to a sub 10. A sub 10, that 10 goes there. 1 minus 3 halves. Okay? We do the math. We multiply all this stuff out. You end up with 174,075 over 512, which is approximately 339.99er.